Good morning. In this video, we are going to see about location of centroid or center of gravity. First, we will see what is the location of centroid or center of gravity. If you take this weight W, which is passing through this center of gravity G. Now, this G is located at a distance of x bar from y axis and y bar from x axis. Now, here the location refers x bar and y bar only. So, in this video we are going to find the value of x bar and y bar only. The first step is I am going to divide the entire weight, this W, into smaller weights, where W1 is the weight of the first element, W2 is the weight of the second element. In the similar manner, Wn is the weight of the last element. Moreover, W1 is the weight of the first element that passes through the center of gravity G1. Now, x1 is the distance between G1 and y axis. Similarly, x2 is the distance between G2 and y axis. In the similar manner, xn is the distance between Gn and y axis. The next step is, if you want to find the total weight W, which is nothing but the summation of all the individual weights from W1 to Wan. Okay, and in the simplified form of this equation is summation of I tends to 1 to n W suffix I. Okay, this will give the value of the total weight. And in my previous video, I told that Variance theorem is going to play an important role. Variance theorem is going to play an important role. Variance theorem says that moment due to resultant is equal to the summation of moment of individual forces. Okay. Now you have to know the resultant, where the resultant comes into picture. For that, again I am going to this diagram. You see that W1, W2, W3 and Wn, all these weights are individual weights, and the total resultant for this individual weight is that W, capital W, or this weight, this total weight, this capital W represents the resultant for all these individual weights. So here R is the resultant. Then the weight W is passing through the center of gravity, and x bar is the distance between y axis and center of gravity. Now if you look closely, this is the perpendicular distance. When we say movement, it is nothing but force into perpendicular distance. So in this picture, W is the resultant and R is the perpendicular distance. So when you multiply these two, you will get the moment due to resultant. This is what I have referred here. W is the resultant and x bar is the perpendicular distance. When I multiply these two, I will get the moment due to resultant, the left hand side of the variance theorem. Now, if you go for the right hand side, you have to find the moment of individual forces. So again I am going to this diagram. W1 is the weight of this first element. This is one of the individual force, and x1 is the perpendicular distance. So when you multiply W1 into x1, you will get the moment of this first weight. Similarly, when you multiply W2 and x2, you will get the weight, you will get the moment for this second weight. In the similar manner, if you multiply Wn into xn, you will get the moment for the last element. Okay, so this is what I have written here. W1 x1 is the moment of the first element, W2 x2 moment of the second element, W3 x3 weight moment of the third element. When you find in the similar manner, and this is the last, this is the moment of the last element. When you add all the individual moments, it will be equal to moment due to the resultant. Next, this equation can be simplified as summation of I1, I2 tends to 1 to n wi into xi, which is equal to w into x bar. Now x bar equal to, I have just brought this w into the denominator, x bar equal to summation I to I 1 to n w into x divided by w. In the place of capital W, I am going to substitute this one. Now this equation will become like this one. So this is my first equation. Now in the first equation, I am going to take this weight. We know that this weight can be written as mass into gravitational constant. Now mass can also be written as rho into volume, where rho represents density and V represents volume. Again, volume can be written as thickness into area. Thickness into area. So the multiplication of density, thickness, area and gravitational constant will give the value of weight. I am going to substitute all these four variables in the place of Wi. So this will become like rho I, Ti, Ai, G and Xi. It's in the similar manner in the denominator also. Now we know that suppose if this entire weight is made up of same material and the thickness is also same, and we all know that the gravitational constant G is also same throughout the earth. So this equation, in this equation, this density will be cancelled, thickness will also be cancelled, and the G will also get cancelled. So the remaining things are x bar equal to summation of I1 to tends to n ai xi divided by summation of I tends to 1 to n ai. So this is the final equation for finding the value of location x bar. In the similar manner, you can get the answer for x bar also, y bar also, but in the place of xi, you have to substitute yi. Okay. So these two are the equations used for finding the location of centroid or center of gravity x bar and y bar. These two are called as method of summation, because here we have used the symbol summation. There is one another method that I will tell you now. In some cases, if the elements are changing from finite to infinite, that means if the number of elements are not able to count, it becomes infinite, then this summation will become an integration, because when n becomes infinity, summation becomes integration. This is a concept, and I am going to take the same weight W, but since it is an integration, I am going to choose a particular small elemental area. You may be asking why here we have taken area, but here we have taken weight. It is not that weight can be simplified as area. Okay, here it is weight, but finally we arrived at area. So here I have chosen small elemental area instead of weight, and this elemental area is located at a distance of x from y axis and y from x axis. Now these two equations will becoming like summation will becoming the like integration, because I am going to find the infinitesimal area, and x is the perpendicular distance, and this is the dA area of the small element. Similarly, y bar, again the same integration. Here y will come into picture, and dA. Now these two equations are called method of integration. Method of integration, it should be used in a place when the number of elements are infinity. Again, these two equations can be called as first moment of area. First moment of area, Normally when I say moment, it is the multiplication of force into distance, but here I have used the area, so it is called as moment of area, moment of area. Moreover, here I have used the term first, so there is another term called second moment of area that I will tell in the next classes. Thank you.